All right, everybody. Well, welcome back. We're going to be talking here about section 5.5 in this video. Um, what's going to be kind of interesting here in this video is we're going to be introducing in 5.5 a brand new type of series, what we call an alternating series. As you can kind of see what I have up here at the start of the notes, I say that so far we've really only been focusing on series which ultimately have all positive terms. I mean, sometimes we allowed for certain terms to be zero, but we never really dealt with series that were able to be negative. To take a look at kind of why this might be the case, take a look at all the different conditions that we've had. Again, we see that we have lots of different types of series that we've come across. But when we've dealt with things like p-series, the harmonic series, geometric telescoping, we had easy ways of testing for those to see if they were convergent or divergent. But when we take a look at the tests, which applied again when I didn't really have one of these types of series, the test for divergence was just saying, well, I gotta check to see what the limit of that a sub n formula is on the inside. That didn't really care whether or not we were working with positive or negative things, but all of the other tests have. Remember, in the integral test, the matching function that I have to create had to have only, or had to be, sorry, positive, decreasing, and continuous. But that key idea of positive implied that the series only had positive terms. The comparison test required that we definitely had non-negative terms. So we were allowing zero, but ultimately we needed things that were positives or zeros. And in the limit comparison test, we couldn't even have zero. We must have had positive terms. So we kind of have this big dilemma that's kind of going on right now, because we could probably easily imagine that not every addition problem is always going to just have positive terms. So what do I do if I come across something with negative terms? What we're going to see is that an alternating series is a special kind of series that we're going to be adding to the list here. And it doesn't have like exclusively negative terms, but it's got some terms that are negative and some are positive. The idea, of course, is that these negatives and positives alternate. So if you take a look back here, we'll see that we give the alternating series the following definition. An alternating series is a series whose terms are alternating between, I'll put here, positive and negative values. So a couple examples of some series that would be alternating could be maybe something like this. Maybe we would consider the following series. This would be, how about a series that starts at 1 and goes to infinity? And maybe it's something like negative 1 to the power n minus 1 over n. I could actually think about what this series actually looks like. Like what are the first couple numbers in this addition problem? In fact, I'd ask, take a moment here really quickly and see if you can write down what the first couple numbers are. If you need to, just pause the video, make sure that you're understanding. So I could see here, if I go ahead and I plug in the value of 1, I'm going to end up with 1 over 1. But then when I plug in a 2, I'm going to end up with negative 1 over 2, and then a positive 1 over 3, and then a negative 1 over 4, and so on and so forth. So I can say that this series is definitely alternating. I can also see here that if I had another series with maybe a slight adjustment, I could get this series to almost be identical to the one that we had listed up above by maybe doing something like this. Notice by doing something like this, I can just kind of change what the, or where the negatives occur. So here, if I plugged in the value of 1, I would get negative 1, and then a positive a half, and then a negative a third, and then a positive a fourth. And it's totally fine to have my alternating series start with something that is positive or start with something that is negative. It doesn't really matter as long as I swap back and forth between these sorts of terms. So one of the things that's kind of cool is to be able to see that with an alternating series, one thing we should note is that we can always express the nth term of an alternating series and we can express it kind of in one of two different ways. We could express it ultimately as something like a -1 to maybe a power of like an n-1, and that kind of has to be multiplied to something like a sub n, like some other formula, but I have to tack on this like -1 to a power to create this alternating effect. Or I could also choose to write it maybe something like -1 to the n, still times that a sub n. So, of course, these aren't the only exclusive powers that I can pick on the -1, but I can see here that based on what that power is, I can make the series start with either a positive or a negative value. And that's really the distinction that we're making here. It's important to keep in mind that in both of these cases, a sub n is typically going to be considered as something positive. Okay. And you can start to see kind of what the a sub n might actually look like in the examples up above. And we'll actually take a look at that first series down here in example 1 as we start to kind of lay out how exactly we would begin to test to see if an alternating series, if this alternating styled addition problem is going to be convergent or divergent. And we'll see that in the next video.